run Python-based tools, so you have some general idea of like how to manage packages, or maybe it's the case you've heard of Python, but you only like, have some vague idea of what it is. And that's totally fine. Like the survey that Allison put out a few weeks ago, kind of, it gives the idea that everyone considers themselves somewhat between like beginner and beginner/intermediate in terms of Python. Like this near to nothing thing. All right.
I think Carolyn was making coffee. I muted her. I'm sorry.
No worries. So I think, yeah, everyone considers themselves like somewhere between beginner or like beginner/intermediate in terms of their Python knowledge. So I think later on in the course, we'll have kind of a more in-depth tutorial that's focused entirely on deep learning concepts. But the demo for today is mostly meant as like a way to get everyone up to speed to some very baseline level of Python knowledge. It's definitely geared towards those who are relatively new to Python and generally new to programming in general. So it assumes you know some stuff about for loops and if statements, but I think everyone in the lab kind of knows that stuff already. So if you consider yourself as anything more than a Python novice, I definitely recommend logging off if you think you're going to be bored. There probably won't be too much new information for you in this talk. But that being said, this is a pretty broad introduction to Python, somewhat in the context of how we can make use of it for our own purposes, which are neuroimaging generally, and also deep learning. So, I'm going to jump around between a lot of different concepts. So if at any point you're lost, just feel free to interrupt. It's meant to be a very interactive session. If I'm going too fast or if you're confused, just like, please stop me. And I should also mention that I'm not really going to talk at all about explicit Python syntax or language structure. I think that kind of stuff is impossible to teach in a 30-minute session, really. I'm not going to say like, this is how you write a class in Python, this is how you write a for loop. I, as a personal opinion, think that stuff is best learned, not necessarily on your own, but kind of at your own pace, either through online tutorials like Code Academy or through some structured, organized courses. So if you're interested in that stuff, and for anyone who doesn't already know about it, there's this Python school that goes on every couple of weeks in the lab. I think they talk about this exact stuff. So there's some great discussions and resources that cover a range of introductory kind of Python coding concepts. It's run by, I think, Jackson, maybe some other people. Honestly, I haven't been super involved, so I'm sorry if I'm leaving anyone out there. But definitely check that out if you're interested. Also, I guess I should probably introduce myself for anyone who doesn't already know me, but I'm Andrew. I'm a software engineer in the lab, and I've been here for a few years, and I spend a lot of my time kind of working in Python and in the realm of deep learning. So if you ever have any questions kind of in those areas, like definitely feel free to reach out. I might not always be immediately available to help out, but I'm happy to help when I can. Anyway, let's get started here. So we can start by asking very broadly, like, what is Python? So Python is what we call a high-level programming language, and it has a bit of a reputation for being a very easy to read, write, and learn language with a relatively low entry point. So it's kind of the go-to language for a lot of beginner programmers because it has this straightforward learning curve and relatively simplistic style and syntax. I think a lot of people, at least nowadays, kind of use Python as their introduction to the programming world, which is pretty awesome. And so what do we mean by a high-level programming language? A high-level programming language is essentially a language that lets you do kind of whatever it is you're trying to accomplish in relatively fewer lines of code compared to say a lower level language, because you don't have to worry about more complicated programming concepts. So to set some context for those who might not know, the language C is very common. It's a very universal lower level language, and a lot of things are coded in C. FreeSurfer is coded in C. A lot of the Linux operating systems are coded in C. And the programs written in it are very fast and very efficient, but they tend to be very difficult to code, especially even for like very simple programming tasks, right? We have to consider all these things like correct memory management, structural rules, or portability across platforms. But in Python, like all of that stuff is abstracted away. You can consider those things if you'd like, but if you don't need it, you really don't have to worry about it. And so, for example, a program written in, say, 100 lines of C code could very well be written in 5 or 10 lines of Python. And that's what makes Python kind of stand out as the right language for our own kind of practical application of scientific computing. Because, you know, oftentimes we're working in the lab and then we might think of some great idea. All we want to do is just code up that idea and test it as quick as we can without having to worry about all of these complicated aspects of low-level programming, right? So it just makes things kind of a lot more accessible to us. Also, you know, Python is considered this interpreted and dynamically typed language. That just means we don't have to compile it to run it at all. So in that sense, it's very similar to, say, MATLAB. And anyone who's very familiar with MATLAB will see a lot of similarities between, you know, Python and MATLAB, or similar high-level languages. So a lot of people have this impression that Python's relatively new, but it's actually been around for about 30 years. So it originally created in 91 by a Dutch programmer named Guido van Rossum. And he's got this quote here that says, essentially, Python is an experiment in how much freedom programmers need. Too much freedom and nobody can read another's code. Too little and expressiveness is endangered. Which, reading it out loud, it sounds a little corny, but I think it's a pretty good mantra for Python, and it kind of describes like how Python's become so versatile for so many different applications. A lot of high-level languages like MATLAB are specific to specific domains. So MATLAB is mostly used for like numerical scientific computing, and other high-level languages like Java, say, are kind of specific for like consumer products. Python, on the other hand, has a lot of applications in advanced web development, backend frameworks and APIs. Pretty sure Dropbox is written entirely in Python still. It's big for game and language development, and it also has a pretty big role in the business and analytical side of things, especially recently. But its biggest impact has been in the world of scientific computing and machine learning, or artificial intelligence, which is, of course, what we kind of use Python for practically in the lab. And I think, I have always thought that Python and these two applications have had this mutual beneficial relationship, because Python has made it very easy for people like you and me to casually deal with deep learning experimentation. And the recent kind of AI revolution, quotes, of the last decade or so also, I think, has boosted Python's popularity substantially. So I was messing around with some Google search trends, and it's kind of interesting to see how like search terms, or popularity in search terms for things like Python and deep learning and TensorFlow, which is a deep learning library, all kind of coincide. And of course, there could be a lot of reasons for this, but I don't think it's an entirely spurious correlation or anything. Like practically every article or tutorial out there that's going over new deep learning techniques is written in the context of Python. So there's really no doubt that Python's played a huge role in this developmental world and experimental world of deep learning. Also, when I was searching through Google Trends, I found that Massachusetts searches Python the most. So good for us. Let's keep it going. So I guess before I get started with kind of the introduction to using Python, similar to last session, it'd be nice to see if like people have very broad or general questions as to like what they'd like to get out of any sort of course or tutorial that's covering any sort of stuff related to Python or Python's use in deep learning. So does anyone have any like big pressing questions they want to cover? Things you want to talk about? Nothing?
I have a more general question, and maybe we'll get into this later too, but I'm sort of curious about FreeSurfer and like what has moved to Python from C, or how Python plays a role specifically with FreeSurfer in the lab.
Yeah. That's a good question. I mean, my personal opinion is that everything in FreeSurfer should be converted to Python because it just makes things easier for everyone from like a maintenance perspective and also a distribution perspective. At the moment, most of FreeSurfer is still written in C. There are a few things written in Python, for example, like Samseg is written in Python. Down the line, that could change, and I'll talk about some things later on to see and to show at least how we can potentially move all the C utilities to Python utilities down the line. Yeah. Anything else before I get started? Again, I'm going to start off very, very kind of like simply from the start. So, anyone who knows Python well, this might not be super interesting for you. But okay, so I guess I'll just get started. So for anyone who is new to Python, I think it's important to start from the building blocks. That kind of sets the stage for how we'd actually use Python in practice to develop different kinds of tools. So, given that we have this coding language, one obvious way we can use it is to just go ahead and write a static program, right? This can be a huge, complex, multi-file, integrated package, or it can just be a very simple script like the one we have here. And so just like in Bash or in C Shell, we can just code very, very simple text files, and then we can execute that text file on the command line. So this particular script just reads a hard-coded text file, opens it up, and then iterates over each line of the text file, then prints the contents out to the screen. So the name of this file is just called print file, and I can just run it like a normal executable in my shell environment. So pretty straightforward. This might seem kind of obvious to some people, but the point is to just highlight that Python can be run like entirely out of the box. You don't have to do anything crazy like use a specific IDE or a special program to develop it, and there's no need to like compile it before you run it. So just like Bash and shell scripting, it's very out of the box, right? And so another cool way we can use Python is to program it with it interactively. And what that means is we can boot up this Python interactive environment and execute lines of code on a line-by-line interactive basis. So we can do this pretty easily in a terminal environment. If we're just kind of in the terminal, we can type Python, and that'll bring us up to this interactive environment called the Python interpreter. And we can execute these pieces of code, line by line, much like we would do in, say, a MATLAB environment, right? So this lets us experiment with code or processes in real time without having to modify scripts or other files and then needing to rerun everything from the start, which is a super tedious process, especially if we just want to, say, change one parameter in our model training or something, right? So a lot of people experiment with Python using this method. And there are other few like user-friendly ways to run things interactively. And we can use interfaces called Jupyter Notebooks, for example, and I'll talk about that at the end. But for the rest of these demos, I'll kind of show everything in this interactive setting. So, one major component of Python is its integration of packages. It's a very modular language, and there are hundreds and thousands of open source packages that are available to us. And so these are packages that have been developed by small scale groups or just general users or hobbyists or even like very large companies. And there's kind of this joke in Python that's if there's anything you're looking to code, there's most likely a package that's already been developed for it because there are just so many packages that are available. And so even the low level kind of built-in utilities that are part of the Python language are divided up into these packages. So for example, if you wanted to do some low level file manipulations, you would import the OS package. Or if you want to do some general command line argument parsing, you use the argparse package, or the JSON package for JSON parsing, or time, for time-based utilities. And there's a whole bunch of these, right? But in addition to these built-in packages, there's also a whole bunch of third-party packages that are available to us, thousands of third-party packages, really. And here are a few that you'll probably see in the realm of neuroimaging and deep learning. And unlike other languages where you don't really use third-party packages that much, in Python, we use them like all the time, right? So especially this top one here, which is called NumPy, which is a numerical processing library. So any sort of math-related or array-related operations, you would use NumPy for. And we can use NumPy as kind of an example package for how you would install packages and then eventually integrate them into your code, right? So Python ships with this standard kind of package manager called pip. It's very easy to use. So to install a package, you can just type pip on the command line and then install package name. In our case, it's NumPy. And pip will pull NumPy from wherever on the internet and then install it locally into your Python distribution. It's pretty straightforward. And also, Python packages are very strictly version controlled. So if you want to install a specific version of a package, you can just specify that in the command line. So we could install NumPy 1.16 here. Right, and it's all pretty straightforward. And that's all you need to run to actually install a particular package. And I can show how we actually integrate NumPy or any sort of package into our code. So I have this fake kind of interactive Python environment here. And so for example's sake, say we have some variable x that's set to an arbitrary array of numbers. Let's say our goal is to take the average of this array. And of course, we could write up a function to do this on our own, but why do that when we have the entire NumPy library at our disposal? So we can import any sort of package and integrate its functionality into our current environment using the import keyword. So in our case, we just do import and then NumPy. This will load all NumPy utilities, like the mean function, for example, into this corresponding NumPy namespace. And so you'll see a lot of these import statements kind of crowded at the top of any sort of Python file or script. And we don't want to have to type out NumPy every time we run any sort of NumPy function. So one thing we can do is import packages under a specific shortcut. We can do this by just saying import NumPy and then as whatever we want to name the shortcut or the alias. NP is a pretty common alias for NumPy. So you'll see that probably in a lot of the examples we talk about in the deep learning course. And so, that's pretty much all I want to say, given a quick introduction to how to import all these packages. And while we're on the topic of NumPy, I do want to say a few things about it. And more specifically, I want to talk about a major component of NumPy called NumPy arrays, right? And this is a core aspect of not just NumPy, but also all numerical processing in Python. So NumPy arrays represent essentially any n-dimensional chunks of numbers. And so people who know MATLAB pretty well will be familiar with this. And we can store this numerical information in 1D arrays or 2D, 3D, 4D arrays, and so on. But for now, we can just consider the 1D case. So again, we have this variable x that's now a NumPy array. This is really not that much different than the kind of standard Python list. But now we have a lot of added features into it. So particularly these are array type mathematical operations. We can also easily extract information about this array structure. So for example, we can inspect its shape or its dimensionality. And because this array is just 1D with 6 different elements, we can print the shape to get a single number 6. We can also get information about its particular data type. And in this case, it's an array with 64-bit integers. Right, and we can also use kind of the standard Python list bracketing to access particular elements of this array. So this line here will set the second element to a value of 10, right? So hopefully this kind of makes sense, and we can extend these concepts into higher dimensions. Because in neuroimaging, we deal with 3D arrays all the time, right? And NumPy makes it super useful for us to process these 3D images. So, say we have this magical function, load MRI volume, that loads an MGZ file or the the image data of an MGZ file into some NumPy array that we'll call image. Just as before, we can access all of these tidbits of information about this image array. So we can print its shape or its dimensionality. And because this is now a 3D array, we get 3 numbers, each with 256 in each dimension, because it's a 256 cubed image. And then also, just as before, we can extract and modify kind of array element information with this bracketing syntax. So say we want to modify some voxel at the XYZ coordinate 100, 100, 128. This line here will do exactly that and set that voxel value to 0. And we can also use more advanced operators like the colon, which indexes everything along a particular axis. And so this line here will say, I want everything in the y-axis in a particular xz plane to equal 0. Right, and with more complex operators, we can do more complicated things. And I'm kind of just showing this as a brief example. You don't have to understand everything that I'm showing here, but for example, this line here will index every other element in the y dimension and add 10 to it. We can also use index lists or masks to specify particular elements in that array. The reason why I'm bringing this up is because there's an important point that I want to make about NumPy processing or any sort of array-based processing in Python in general. And that's kind of throughout this course, you'll encounter many programming tasks that involves images or maybe even surfaces. And these tasks involve iterating over millions of voxels in an image, or potentially tens of thousands of vertices in a surface. It's important to know and remember that it's never a good idea to actually iterate over each element in an array one at a time. It's almost always a good idea, or a better idea, I should say, to use this advanced NumPy indexing to do whatever you're trying to accomplish. So I'll try to highlight why this is important in a short example here. So say we had this programmatic task where we're making a function where we have some input image, which is just a standard array of brain data. And we have a corresponding image or an array that's also in the same space as our input image, but it's essentially a brain mask. So any voxel that is non-brain is 0, and we'll say any voxel that is brain is 100, right? So the programmatic task is for every coordinate in the mask, where the voxel value is 0, we want to set the corresponding image coordinate to 0 as well. So it's essentially a very simple masking algorithm. And so for those of you who don't really have any Python or similar MATLAB background, the intuitive way to code this up would probably be to say, all right, I'm going to iterate through each voxel in each dimension in the image. And then for that given coordinate, I'll say if the mask is equal to 0, then I'll set the image at that coordinate also equal to 0. Now, in theory, this is a totally valid way to implement this task. If you were writing it in C, it would be very fast. But it's important to remember that in Python, it's not a compiled language. So for every iteration in the millions of voxels in this image, it's allocating all of these inefficient Python objects. And it actually takes a full 32 seconds to run this block of code, which is super, super slow for such a simple task, right? If everything in Python took this long, like, no one would use it. The more kind of, in quotes, right way to do it is by using this advanced NumPy indexing techniques. So we can consider this problem by saying, what I really want to do is find every index with a mask equals 0, and then use that index in the image to set the image to 0 at that same location. So we can set this variable not brain that represents where the mask is equal to 0. And this is a set of coordinates, essentially. And then we can apply the set of coordinates to our image and say, everywhere in the image that's not brain, I want that equal to 0. Right? And so these two lines are all we need. And this version of the implementation actually runs in a fraction of the time as the first one, right? It's like 100 times faster, and it's on the order of milliseconds. So it's critical to kind of consider these types of things when coding in NumPy arrays, which I assure you definitely will be using a lot of NumPy arrays in the deep learning course, or tensors, which are the deep learning versions of NumPy arrays, essentially, for simplistic purposes. Right, so if you don't fully understand what's going on here, I think that's okay. The idea is to kind of just plant the seeds that, a general rule of thumb is if you're looping through arrays, then there's most likely a more efficient way to do what you're trying to do, right? So that's kind of all I wanted to say regarding a short introduction to NumPy. Does anybody have any questions about that stuff so far? Hopefully that wasn't too all over the place for everyone. Nothing? All right. So, NumPy isn't the only cool package that we'll be using in the deep learning world. Another very common package is matplotlib, which is used for all things related to plotting in Python. So you can use it to do quick graphical visualizations or actually create publication quality graphs. The nice thing about it is that it's also interactive. So we can load it up in this interactive environment. It's a pretty long package name, so people usually refer to it as PLT. We're just generating some fake data here. And we can generate these plots, and this is just a linear plot. The nice thing is we can just interact with it even after we've brought the figure up. So we can add lines to the plot, or we can do things like change the title, for example. Another nice thing is that matplotlib works very well with images. It's useful for 2D visualizations, which of course is a big role in the stuff we want to do. And on that topic, there are plenty of other packages that are useful for our own neuroimaging purposes, right? So a few that you'll probably see in the endeavors are SciPy, which isn't specific to medical imaging, but it's this advanced kind of engineering and scientific library that has a lot of image-based utilities like Gaussian filtering, convolutions, and things like that. NiBabble is also a nice package that provides read and write access for a lot of common neuroimaging file formats. Neurite is something we'll be using a lot. This is a library that's originally was initiated by Adrian, and it contains a lot of very useful utilities for deep learning in the context of medical imaging. And then lastly, we have Surfa, which is a newer kind of work in progress package that I've been working on. And it contains a set of utilities for neuroimaging and cortical surface reconstruction. And it's somewhat meant to be kind of this Pythonized version of the common C FreeSurfer utilities. And so as people in the lab continue to develop Python tools, I hope that this will be very useful for that purpose. And I was going to give a much more detailed demo, but I think it would be overkill here. So instead, I just put together this quick teaser video to showcase some of the kind of basic features. So we can import it. Oh, this video is not working. Oh, never mind. Yeah, it is. So we can import Surfa as whatever you want, really. And at its most basic form, it can be used as an I/O tool, right? So we can load any sort of volume file, whether it's MGZ or NAI, and then extract a lot of information about it, just like we would a NumPy array. So we can see its shape, its voxel resolution. The nice thing is that we can also kind of use this to interact with FreeView from a Python environment. This is super useful for general debugging purposes, whether or not you're using it for kind of coding or just inspecting the results of some deep learning analysis or whatever you want. There's also a lot of utilities that are built into the volume and image objects. So we can reslice images to a particular voxel resolution. In this case, we can reslice to 6mm resolution and visualize that in FreeView. We can also handle transformations. So affine transforms and dense transforms can be loaded with the library and then applied to particular images. So in this case, we're transforming our input image with an LTA, a linear transform that we loaded. Again, we can visualize this in FreeView. And there's also full support for surface IO. And then each surface object also has full access to the underlying vertex information and face information. So we can modify all of that stuff under the hood. And then once again, we can visualize any sort of surfaces with preview. So that's about kind of it in terms of what I wanted to show. There are a lot more features to come, and a lot of, especially for surface-based things. And I should also mention that the package currently exists and has been developed for a long time under the name FreeSurfer in the FreeSurfer repository. But for a variety of reasons, we needed to rename that. So if anyone has any suggestions for a new name, or if they like hate Surfa and say, I hate this name, but come up with something new, just let me know. We can try to see if we can rename it to something better. So the last thing I wanted to talk about, which is packages for machine learning or deep learning. And I was going to spend a lot of time talking about these in more detail, but I think it's probably best to wait until Adrian gives gives the second part of the introduction to deep learning, because this can be rather technical. So instead, I'll just mention that there's pretty much two main Python packages that dominate the current area of deep learning, and that's TensorFlow and PyTorch. And they're both very instrumental in the sense that they've allowed people like you and me to experiment with very complicated deep learning models very easily. A lot of people like to argue that one is better than the other, but the reality is that at the end of the day, they're pretty similar. So TensorFlow and PyTorch are two things to keep in mind, and we'll definitely be visiting those kind of later on. So I'm skipping through all this optimization stuff. Any questions so far about packages?
Andrew, is there a list of the tools that are available in Surfa somewhere, or will you make one? I mean, it sounds,
Yeah, I should probably make something. Like, I was planning on putting together a bunch of documentation and just linking everyone to that. At the moment, it's still kind of a mess, still kind of work in progress. But yeah, that's a good idea. Any other questions about packages or whatever?
Andrew, good presentation. And maybe this is related to what Adrian was just talking about, but like for Surfa, like where do you get documentation for things like if you wanted to gain access to like the XYZ coordinates, do you just look inside of the Python file and see like, what elements are in the class, or is there like some kind of documentation for that?
I guess so. I mean, there really should be documentation that kind of talks about all those things. Most big packages have that. But if there isn't, if you're using a Python interactive environment or an IDE, you can usually extract a lot of useful information just from the interpreter. So, if you're messing around in the terminal, you can tab complete any sort of member functions or parameters for the actual class. And you can usually use the help keyword to get information about particular parameters in that object. But I think the best answer should be that there should be like very, very explicit documentation on this stuff somewhere online, which will come eventually.
But like right now, if I wanted to start using Surfa, like, would I just go to the surfa.py and the FreeSurfer repository and just see what's in the classes, and just try to
in
infer
terms of the
things from that?
actual code? Yes.
Yeah.
And right now it's in the FreeSurfer library under like Python/FreeSurfer.
Yeah.
If you want to take a look.
Okay, thanks.
Sure. Any other package related questions? I kind of wanted to save some of this stuff, the more technical stuff like setting up Python, for the end. Any general questions? No? So setting up Python is a question that I get pretty frequently, and for good reason, because it's kind of complicated. Even people who are like pretty familiar with Python tend to run into these problems. So I'll give a quick overview of kind of what that entails. And so Python is usually installed on most people's systems by default. And the command which Python will let you know which Python you're actually using when you call it in your terminal environment. And most likely this will point to somewhere in user bin Python or user local Python or user pub SW. And that's totally fine. It's kind of the default. But if you want to actually start experimenting with Python, you really want to start using your own version, or at least the version that we have installed at the lab. Because these packages don't allow any permission to install, or these Python versions don't allow any permission to install your own packages. So one option is to use our lab's kind of local Python installation. And you can add this to your path, and there's some instructions under the Python wiki on the FreeSurfer website. But you still won't be able to control the packages here. So you can email me if you want anything installed. But if you plan on developing a lot in Python, I think the best move is to actually install it yourself. And instead of installing Python directly using the command line, it's best to use a package manager called Anaconda. And the reason why we want to use Anaconda is because it can create these isolated environments that are really useful for development across different applications. So let's consider this situation where you have one tool that you're developing or using that has these given package requirements: NumPy 1.16, SciPy 1.7, and TensorFlow 1.3. And then in parallel, you're also developing this tool that uses the same package but requires completely different versions of those packages. This is a total incompatibility. And it's very difficult to develop this if you don't have a package manager like Conda installed. So, you might be developing tool 1 and you pip install all the necessary packages. And then all of a sudden you want to work on Python tool 2, and then you have to uninstall and reinstall all the new stuff. So the solution is to use Anaconda to create 2 separate development environments. So you have this Conda environment 1, where you've installed all these specific versions of this package. And then you have Conda environment 2, where you've installed these other versions. And you can very easily switch between the two, depending on which tool you want to work on at that moment, right? So here's a quick example. So say I've had this tool where I want to install a specific version of NumPy. I can activate this environment in a particular terminal environment or shell environment, and then install NumPy 1.16 with pip. But now separately, I want to work in an environment where I also have a different version of NumPy installed. So in a different shell, I can activate a different Conda environment. We'll call it my environment 2. And then we can install whatever version of NumPy we want. In this case, 1.19, which is, I think, the current version. So we have 2 separate shell environments that are both accessing, in theory, the same Python, but are using 2 completely different environments with 2 completely different versions of packages installed. So the way you can set this up is by going to anaconda.com and then downloading their bash installer script. And you can just run that script on the command line, and it'll walk you through the instructions for how to install this into your environment. And it might change your startup files a bit. And I'll put up some documentation on the wiki to describe how you can avoid that. But for the most part, this is the best way to install Python on your machine if you want to actually start developing with Python tools. Okay, I mean, that's kind of all I had prepared. If people want, I can spend some more time talking about how you'd go about installing things or using different environments. But I did want to save some time for just a general discussion about this stuff. We also want to spend some extra time at the end just for anyone who has questions about general deep learning stuff. So I think that's it. Thanks.
Thanks, Andrew. I just want to emphasize to everybody that having a very well set up environment can save you a lot of time down the road. So I highly recommend spending the time to understand, how to set it up and having one.
Any other questions regarding Python? Things I should show people?
Andrew,
Any
if
deep,
there's no
any
other,
deep learning questions?
Yeah, people can ask anything. If people don't ask questions, I was curious if you could just talk about what other stuff you might have in Surfa or in plan for Surfa, because it seems, a lot of people want to use and often use free Surfer tools, and it'd be really nice to know what is making it into Surfa.
Sure. So, like from an image perspective, there have been, like Nibello, for example, is a Python package that's been around for a pretty long time, and it's very useful for I/O. So you can read any sort of image format and write any sort of image format. But kind of in the context of deep learning, oftentimes we develop these models that are trained on images that are oriented in one specific way, and they're cropped to a particular image size. And it becomes very difficult to keep track of header information. So information that defines the geometry of those particular images. The Surfa library hopefully kind of solves that problem. So you can crop images, you can transform them, you can resize them, you can do all this stuff, and all the header information is retained. That's super useful for distributing deep learning tools, right? So it's meant to kind of make that process easier. And from a surface perspective, there really aren't any surface tools available for Python. There's plenty of general mesh libraries, but nothing related to cortical surface reconstruction. So with the library, hopefully we can add a bunch of surface-based utilities that exist in the FreeSurfer-C library. But there's already a few things that already exist in there. So for example, spherical parameterization, that's in there at the moment. That's something that's kind of difficult to do in C, but in Python, you can just essentially do it in one line after loading a surface. And then maybe eventually we'll add utilities that can convert most of the FreeSurfer pipeline into Python. I think that'd be very cool. I should definitely get like a more detailed teaser video set up for everyone. I think that'd be nice. If anyone has like suggestions too for what I should include in this package, definitely let me know. Anything else? If people who are very new to Python have more questions, I'm happy to do another kind of shorter session with a smaller group at some point this week. I know it can be tough to like ask a bunch of questions in a group of 30 or so people, where you might not know everyone. So just reach out if that's the case. Nothing else?
I guess I could have a question, Andrew. Can you hear me?
Yep.
Okay, cool. Yeah, so what's an example of complicated importing? Would it be, say, one package, or package A requires a specific version of package C, and package B requires a different version of package C? Like two different packages require different versions of the same package. Is that are complicated.
Right, exactly. And that stuff happens all the time. And it can be very annoying. So this problem was solved by these conda environments that allow you to just make these isolated set of packages and then switch between them. But right, exactly.
But what if you, in the same environment, you have this conflict? You want to use this?
Oh, I see what you're saying. Usually, I mean, that definitely complicates things. This doesn't happen as frequently because usually packages that you're downloading from pip or whatever that are more formalized tend to take care of this on their own. But some people, you know, they put out these different machine learning packages and they kind of just code it up once and release it and then don't revisit it. In those cases, you know, you probably have these conflicts that you're describing. Okay. There's really no way to kind of deal with that if you're trying to integrate two packages that both use a different version. But it's kind of, I guess, at that point, up to you or whoever developed it to fix it.
I think, doesn't PyPy allow, or pip allow you to rename a package? Like if you have like, you know, numpy old, I think, does it not allow you to do that? I feel like it did, but maybe not. Like in a particular environment.
Yeah.
And the other thing I want to say is an additional thing for Rob is it starts getting complicated also a little bit when you have your own packages, or you're trying to import stuff from your own package that you're building. You just have to be careful with the relative paths and stuff like that. It's not, I think it's not very complicated when you get to Andrew's level of understanding how it all works, but it's complicated at the beginning.
Sounds good, thanks.